Good day everyone, I'm Lablaros Bulusar. Today, my report today is all about in 3.4 to 3.6. First is increasing and decreasing functions on the first derivative test. In 3.5, concavity points of inflection and the second derivative test. 3.6, sketching graphs of functions under derivatives. In 3.4.1, definition of an increasing function. A function f defined in an interval is increasing on that interval if and only if f of x sub 1 is less than f of x sub 2, whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval. In 3.4.2, definition of an increasing function. A function f as defined on an interval is decreasing on that interval if and only if f of x sub 1 is greater than f of x sub 2, whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval. While in Theorem 3.4.3, let the function f be continuous on the interval, closed interval e and b, and differentiable on the open interval e and b. If f prime of x is greater than 0 for all x in open interval e and b, then f is increasing on closed interval e and b. In number 2, we have if f prime of x is less than 0 for all x in open interval e and b, then f is decreasing on closed interval e and b. Okay. Illustration 1, figure 2 shows the graphs of f of x is equal to x cubed minus 3x squared and f prime of x is equal to 3x squared minus 6x. This is the result of this kan siya. Nganong nani siya is because gi-derive siya, first derivative. Okay, 3x minus x is 3 times x equals 3x, and then 3 minus 1 equals 2. That's why the result is 3x squared minus this 3 times 2, 2 times 3 equals 6. Therefore, the result is 3x squared minus x. This is the derivative, first derivative of x cubed minus 3x squared. Okay, plotted in the same closed interval negative 5 and 5 by negative 5 and 5 window, observe that when x is less than 0, f prime of f is increasing on negative infinity and 0. When 0 less than x less than 2, f prime of x is less than 0, and f is decreasing on closed interval 0 and 2. When x is greater than 2, f prime x is greater than 0 and f is increasing on positive 2 and positive infinity. Okay. As you can see in the graph, this muna resulta sa f prime of x. This is the graph. This. And this the f of x is equal to x cubed minus 3x. Muna siya. Muna siya ang sa graph. In proof of theorem 3.4.3, let x sub 1 and x sub 2 be any two numbers in closed interval e and b such that x sub 1 is less than x sub 2. Then f is continuous on x sub 1 and x sub 2 and differentiable on x sub 1 and x sub 2. From the mean value theorem, there is some number c in x sub 1 and x sub 2 such that f prime of c is equal to f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. Because x sub 1 is less than x sub 2, then x sub 2 minus x sub 1 is greater than 0. Also, f prime of c is greater than 0 by hypothesis. Therefore, f of x sub 2 minus f of x sub 1 is greater than 0. And so, f of x sub 2 is greater than f of x sub 1. We have shown that f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2, where x sub 1 and x sub 2 are any numbers in the interval, closed interval a and b. Therefore, by the definition 3.4.1, if is increasing on closed interval a and b. Okay, let's continue. In 3.4.4 theorem, that first derivative test for relative extrema. Let the function f be continuous at all points of the open interval a and b containing number c, and suppose that f prime exists at all points of e and b except possibly at c. Okay. If f prime of x is greater than 0 for all values of x in some interval having c as its right endpoint, and if f prime of x is less than 0 for all values of x in some open interval having c as its left endpoint, then f has a relative minimum value at c. Okay, next is if prime of x is less than 0 for all values of x in some interval having c as its right endpoint, and if prime of x is greater than 0 for all values of x in some open interval having c as its left endpoint, then f has a relative minimum value at c. Okay, 3.5 concavity points of inflection and the second derivative test. And 3.5.1 definition of concave upward. The graph of function f is said to be concave upward at the point c, f of c, f prime of c exists. And if there is an open interval I containing c such that for all values of x is not equal to c in I, the point x, f of x on the graph is above the tangent line to the graph at c, f of c. Okay, in 3.5.2, definition of concave downward. The graph of function f is said to be concave downward at the point c, f of c, f prime of c exists. And if there is an open interval I containing c such that for all values of x is not equal to c, in I the point x, f of x on the graph is below the tangent line to the graph at c, f of c. Okay, here is the illustration. Figure 2 shows a portion of the graph of function f concave at the point c, f of c, and figure 3 shows a portion of the graph function concave function f concave downward at the point c, f of c. In figure 2, this is the concave upward. As you can see, the c, f of c is the concave upward. Okay. While in figure 3 is concave downward. The CF of C is concave downward. Okay. 3.6 sketching graphs of functions under derivatives. From this graph, determine the abscissas of any points of inflection of the graph of f and where the graph of f is concave upward and concave downward. As you can see in the graph, here is where is the concave upward. Ang concave upward kani siya this concave upward, while this point kani siya is concave downward is because pa negative siya padulong. Pa downward siya kung negative ang result, and then pa upward siya kung positive. Okay? Okay, here is the solution. The second derivative f evaluated the number c as the slope of the tangent line at the point where x is equal to c on the graph of a prime, and consequently, because the graph of a prime and second derivative of f is 3 is equal to 0. We observe from figure 1 that e prime is increasing. That is, second derivative of f of x is greater than 0 when x is less than negative 1 and x is greater than 3. The graph of f is concave upward for these values of x. Furthermore, f prime is decreasing. That is, second derivative of f of x is less than 0 when negative 1 less than x less than 3. The graph of f has points of inflection where x is equal to negative 1 and x is equal to 3. We summarize in table 1. So, nasa table. Okay. In table 1, here is the table 1. X is less than negative 1. Then, second derivative of f of x. This is the result na siya. Kung derive naman siya dire, and then himo siyang positive. Therefore, ang conclusion is graph of f is concave pa upward siya. It's because kung concave upward gali ang kung positive ang result is the graph is concave pa upward. Okay. And then x is equal to negative 1 and the result gi-derive naman siya no into second derivative siya. The result is 0. The graph of f has a point of inflection as a point of inflection because 0 ang iyang result. And then negative 1 less than x less than 3. Therefore, ang result is the second derivative gihapon siya of x. Therefore, the result is negative. And the conclusion is graph of f is concave downward. Why is it concave downward? Because kung ang graph, kung ang result is negative, then therefore iyang graph is concave downward. Okay. Next is x is equal to 3. So, maghapon siya, derive gihapon siya. And then, the graph of f has a point of inflection. 0 man result. So, nasa sa point of inflection. Okay. And while last is 3 is less than x. Therefore, ang result is positive. Then, the conclusion is graph of f is concave upward. Okay. That's all my report, and thank you classmates and thank you sir for listening. God bless everyone.